this lecture we are going to start with the non-linear equations. Non-linear in the sense you can say reducible to linear equation form, right? So we are going to start with the reducible to linear form, dear students, where we will learn how to reduce a non-linear equation into the linear form, which is also called the Bernoulli's equation. So the other name of this one is Bernoulli's equation, which is very, very famous. Okay. So let's have discussion. I will tell you the complete description, complete information or complete description about how to approach a non-linear equation and how to convert that non-linear into a linear form. Okay, and then we will have discussion how to find the solution also. So let's have discussion, dear students. What is the difference between linear and a non-linear equation, right? So whenever we have a differential equation is of the form, a differential equation is of the form, we already have the form written on the board. So still let me write down dy by dx plus py is equals to qy to the power n. dy by dx plus py is equals to qy to the power n, where p and q are function of x only, right, as we know very well. So where p and q are function of x, right, that we know, but here it's not a linear equation. Why? Because you can see the focus on here also the p and q should be the function of x only, that we know very well, these should be function of x. But when we talk about this one here with the q, we having a y also. So along q we are having a y also. So this y will not allow to convert my differential equation or to be my differential equation set to be a linear equation. So that's why this y to the power n I have to, this y to the power n I have to remove to make my differential equation as a linear, right? So whenever we have this type of equation, that is called a differential equation is of the form, this one is called Bernoulli's, okay, or more and more you can say Bernoulli's equation, or it is non-linear equation, right? So non-linear equation or reducible to linear equation form. So how we can approach it? So dy by dx plus py is equals to qy power n here, dear students. We have to convert this one. We have to just remove this y power n from there only, right? So how we will approach? Let me show you the complete method. Let me show you the complete method how we will approach. So first of all, whenever we have the equation dy by dx plus py is equals to qy to the power n, yes, we will just divide y power n from, we will just divide y power n from each and every term, right? So it will become y to the power minus n dy by dx. When we divide here, it will become y to the power 1 minus n, yes, and it will be q only. Now my q is free from the y power n, as we can see easily. Now here we don't have any term of q or y, right? But still it's not a linear form. We have to make it more clearly, because again it's y power minus n and y power 1 minus n are exactly not exactly allowing our equation to make the linear equation. So what we have to do, dear students, we will use the substitution, right? So we will substitute the thing. So let us assume y to the power 1 minus n is equals to y to the power 1 minus n is equals to z. So when we substitute this one, right now our equation is in the form of y and x, right? You can see it is including p and q. But when we substitute at the place of y to the power 1 minus n is equals to z, then your equation will convert into z and x only. Okay, so that will be helpful to making the equation in the linear form. So let's approach it. Z is equals to y to the power, okay, more and more you can write down. Let z is equals to y to the power 1 minus n. Let's find dz by dx. When we approach it, it will be 1 minus n minus 1. Okay, sorry. It will be 1 minus n into then 1 minus n minus 1, right, as we know very well. So it will be y to the power minus n minus 1 and minus 1 will be cancelled out. So hence dz by dx is equals to 1 minus n into y to the power minus n. Yes, exactly. So this will be your this will be your this will be your substitution portion. So in this particular equation you can substitute at the place of and it's including dy by dx, right? So in this particular equation you can substitute at the place of y to the power minus n dy by dx as let me write down, it is 1 by 1 minus n yes into dz by dx, right? So we can substitute this one at the place of y power minus n dy by dx. Let's substitute and let's convert the equation into the form of z and x only. So when we substitute, dear students, it will become what? Y power minus n dy by dx, it will be 1 by 1 minus n into dz by dx, yes exactly, plus it will be p, and y power 1 minus n is nothing but z is equals to q. Now your equation is looking like this one. As I already told you earlier, the equation is in the form of y and x. Now it's in the form of z and x including p and q, right? So we can make it, we can write down just like this. Okay, we can make it more simple just by writing this dz by dx plus p into 1 minus n z yes is equals to q into 1 minus n. Now this is your linear differential equation in the form of z and x, dear students. This is the linear differential equation. You can say dy by dx plus py is equals to q form. Here you can see dz by dx plus p into 1 minus n z is equals to q into 1 minus n form. So hence this is your linear, okay, this is your linear differential equation. So you can write which is linear. Now if it is linear, how we will find out the solution? So in the linear differential equation, we know very well we will find the solution in the two patterns. First of all, we will find we have to find integrating factor, then we have to go for the general solution. Yes, so it will be dz by dx plus p into 1 minus n yes into z is equals to q into 1 minus n. Yes exactly, we are having. So let's approach it. Let's approach it. Dz by dx is equals to p into 1 minus n, z is equals to q into 1 minus n. So what will be the integrating factor? So exactly in this form the question has been written for you. Whenever the question is of the non-linear or the reducible to linear or the Bernoulli's equation form, in this pattern exactly the question has been written each and every time. So you have to find the solution from here. So you will find out integrating factor. Your integrating factor will be e to the power p 1 minus n into it will be dz. Okay, it will be, now let's have now let's have discussion. When we have dy by dx, it will be dx here. So when we have dz by dx, it will be dx only, guys, right? So there is no difference between in the integration portion only a slightly difference which we have is we always include 1 minus n with the p. Whenever we have to find the integrating factor, we will write down it is e to the power p 1 minus n into dx. Okay, this will be the integrating factor. Let's talk about the general solution. So as we know very well, the general solution is always is equals to y into integrating factor is equals to q into integrating factor dx plus c. So this time it will become z into integrating factor, right, is equals to q into 1 minus n into integrating factor and dx plus c. Okay, now if you think that ma'am exactly when we have equation in the given question, okay, so it will be in the dy by dx form. So how we will approach it? So more and more you can write down, dear students, at the place of z what we substitute, you can write down the value of z. So you can say it is y to the power 1 minus n into integrating factor is equals to q into 1 minus n into integrating factor into dx plus c. So this will be your final solution, right? So this will be the general solution, dear students. Is it clear? So we have to find out only two things. The first is the integrating factor, yes, and the second is the general solution. So hence we can conclude that the general solution will be y to the power 1 minus n into integrating factor is equals to q into 1 minus n. So there is only slightly difference between a linear between finding the solution or the integrating factor between the linear and the non-linear. What exactly the difference is? Here we always have 1 minus n, so we have to include 1 minus n in our integrating factor also, and we have to include this 1 minus n in our general solution also. Is it clear? And the second thing, we used to write down y into integrating factor in the linear equation, but here in the Bernoulli's we have to write down y to the power 1 minus n into integrating factor. Okay, so there is no need to do each and every step. This is just a description which I just showed you to exactly finding what we are proceeding. Okay, how we are converting a non-linear equation into a linear equation. I am just showing you this thing. This was a non-linear equation, and when we converted this non-linear into a linear equation. Okay, but there is no need to do like this. You have to focus on this one only. Your question should be written in this form, or either in this form or in this form. Okay, whatever the question you have, either that can be in this form only. Okay, this is also a non-linear form, exactly in the form of dy by dx. So usually you will have question in this form only. So whenever you have question in this form, you have to write down 3 things from this question. Okay, what exactly? You have to write down the value of p, you have to write down the value of q, and you have to write down the value of n. From the given non-linear equation or from the given Bernoulli's equation, you have to write down only 3 things: the value of p, the value of q, and the value of n, right? After that you will come to here only. So it will be your integrating factor. Integrating factor will be e to the power integration p 1 minus n dx, and it will be your general solution y to the power 1 minus n. Integrating factor is equals to integration q into 1 minus n into integrating factor dx plus c. Okay guys, is it clear to everyone? So I think now you are getting my point. It's a very simple thing to approach. Done guys? Now so I think it's clear to everyone. Now let's approach to the question. Okay, now I will show you which type of question frame from here. So let me write down one question, one example for you. Okay, and generally in general, whenever we have Bernoulli's equation, the question has been asked for the finding integrating factor only. So actually finding general solution is quite lengthy in this process, but still the question has been asked in the GET examination based on the integrating factor only. Still I will show you one question with the integrating factor and general solution, and remaining we will have discussion. Now let me write down an example for you guys. Okay, let's have discussion on one more thing. This was the equation when we have dy by dx form. This is the process when we have dy by dx form. If we have dx by dy form, then how we will approach? Let me show you. If we have dx by dy plus px is equals to qx to the power n form, then how we will approach? The process will be same, only with the slightly difference. The integrating factor will be, in that case also you have to write down the value of p, you have to write down the value of q, and you have to find the value of n, right? In that particular case also you have to write down the value of p, q, and n, guys. Yes. Okay, so your integrating factor will be e to the power p 1 minus n into, now this will be dy. Okay, as we know very well, for the x we have x, and for the y we will have dy, and your general solution will be x to the power 1 minus n into integrating factor, it is equals to q into 1 minus n into integrating factor into dy plus c. Is it clear guys? Right? So this will be your solution when you have a differential equation like this. So this will be your integrating factor, and this will be your general solution. Okay, now let's approach to the question. So let me write down an example for you. Find the solution. Let me write down an example. Find the solution of the differential equation of the given differential equation. Find the solution of the given differential equation dy by dx plus y by x, dy by dx plus y by x is equals to, we are having x cube y cube. Yes, exactly. Y by x cube y cube is. Okay, now let's find the solution. Okay, first of all we will proceed to the integrating factor, then we will find the solution. So as I already told you, okay, let's check first. Either it is a let's check first whether it is a non-linear equation, means it's a Bernoulli's form or not. So how we can approach? We can say dy by dx plus py is equals to qy to the power n. Can you see here? It is the form exactly with having dy by dx plus py is equals to qy to the power n. Now what is p? P is nothing but 1 by x. What is q? Q is nothing but x cube. What is y? Power n. Y power n, it means it is y power 3 only. Yes, exactly we are having like this. Yes, okay. So we have to find the solution. Okay, let's find the solution. So as I already told you, whenever you have the differential equation like this, you have to write down the three things, p, q and n. Just write down what is p. P is 1 by x. What is q? Q is x cube. What is n? N will be 3 only, right? So we are having exactly p, q and n. P, q and n we are having. Yes, exactly. So p, q and n we are having. Let's approach to the integrating factor first. So when we check the integrating factor, it will be e to the power p 1 minus n into dx plus, okay, dx into dx only, right? So this will be my integrating factor. Let's approach to the integrating factor. It will be e to the power p. The value of p is 1 by x, 1 minus n. So it will be 1 minus 3. 1 by x into 1 minus 3 into dx. Okay, yeah, is it clear? Let's write down here only. So your integrating factor will be e to the power p 1 minus x. It means it will be minus 2 by x dx. Let's approach it. It will be minus 2 into log x. Yes, to the base e. Let's approach it. It will be log of x to the power minus 2 and e. Hence it will be 1 by x square only. So you will get finally the integrating factor as 1 by x square only, guys. Is it clear? Yes. So this is the integrating factor we are having. So finally the integrating factor is 1 by x square. Now we have to find the general solution. Let's find the general solution. So as I already told you, although there is particularly a fixed pattern in the GATE examination, so whenever we have Bernoulli's type of equation, the question has been asked only and only based on the integrating factor. But still, if you want to find the solution, we can go for the solution also. So we know very well the solution is y to the power 1 minus n. Yes, integrating factor is equals to q into 1 minus n integrating factor dx plus c, right? So let's write down here y to the power 1 minus 3. Integrating factor is 1 by x only. Q is the value of q is x cube only. Just remember one thing, because in general we have the equation dy by dx plus py is equals to q into y to the power n. So hence your q will be only and only x cube, right? Because we know very well whenever we have to approach with the linear, p and q should be the function of x only whenever we have the differential equation in the form of dy by dx. So that's why we will not include y to the power 3. Okay, this y to the power 3 is only and only to finding the value of n. Okay, now let's approach to this one. So q will be x cube. Yes, 1 minus n means 1 minus 3. Integrating factor is 1 by x dx plus c. Okay, let's approach it. So when we approach it, so guys, it will become 1 by x into y to the power minus 2. So we can write down 1 by x y square. It will be minus 2, x and x will be cancelled out. So it will be, you will have minus 2 is outside and x square dx plus c. So let's integrate it. It will be 1 by x y square is equals to minus 2x cube by 3, guys, and plus c. So you can conclude your answer will be like this only. Okay, whenever we have options, we can make changes according to the options, right? So finally, right now we can say the answer will be 1 by x y square is equals to minus 2x cube by 3 plus c. Okay, so this will be my final answer. Is it clear, guys? Right? So this will be the approach whenever we have to go for the Bernoulli's equation and we have to find the general solution. We will approach like this. Okay, just remember one thing, when we have to approach with the q, so q will be only this portion, right? As we can see very well, it's the equation. When we compare the things with the equation, dy by dx plus py is equals to q into y to the power n. So this y to the power n will not included in the general solution. Okay, means this y to the power n will not included in the q. Okay guys, now done. So okay, let's have discussion on one more question, and this time I will ask to you what exactly the GATE examination has been asked, that to finding the integrating factor only. So let me write down one more question of the Bernoulli's. So find the integrating factor. Find the integrating factor of dy by dx into dy by dx into xy plus x cube y cube is equals to 1. Let me cross check the question. X cube y cube, yeah, exactly we are having dy by dx into xy plus x cube y cube is equals to 1. So we have to find out the general we have to find out the integrating factor. Let's convert it. So when we convert it, exactly you can see here it's exactly not fitting in the dy by dx form. So we have to make definitely some changes in this form. So it is looking like dy by dx is equals to 1 by xy plus x cube y cube. So we can say it's definitely not a Bernoulli's form. It's definitely not a linear, and it's also not a Bernoulli's form. So we have to convert it into the dx by dy form, because with the help of dx by dy only we can approach this question. So it will be dx by dy is equals to xy plus x cube y cube, guys. Yes, exactly. So what we can write down? We can write down it will be dx by dy, yes, minus xy is equals to x cube y cube, yes. So this is the differential equation of the form dx by dy plus px is equals to q x to the power n, right? We can see easily. So from here, from this differential equation, we will write down only three things. We have to write down value of p, we have to write down the value of q, and we have to write down the value of n, right? So what will be the p? As you can see, p will be what? Py, when we approach to this one, the p will be, okay, it was earlier it was 1 by x, but when we approach to this one, my p will be minus y only, yes, exactly. And the q will be y cube only, yes, exactly. And n is equals to 3 only, because we know very well whenever we have this form, so your p and q are function of y always. So that's why p is equals to minus y and q is equals to y cube. Okay, let's find the integrating factor, and it is already talking about integrating factor p to the power 1 minus n into dy. So when you will approach e to the power p, what is the value of p? Is minus y, 1 minus n, it means the n is equals to 3 only, guys. You can see easily your n is equals to 3, right? So when you approach it, it will be dy only. So when you approach, it will be e to the power minus plus 2y dy. Okay, let's integrate it with respect to y only. So when we integrate, it will be 2y square by 2. 2 and 2 will be cancel out. So hence your integrating factor will be e to the power y square only. So it's already talking about only and only integrating factor. So it will be e to the power y square only. If it talks about the solution, then you can go for the general solution. From here only, the process I already told you. In that particular question, the general solution will be x to the power 1 minus n into integrating factor q 1 minus n into integrating factor into dy plus c, right? Exactly, we know very well. So exactly, right, guys? So it will be like this only. So when we have, you can see easily, when we have this one y power 1 minus n, we have dx here. When we have x power 1 minus n, where it is, yes, it will be dy here. So we can easily approach the question. Okay, so although it's not talking about solution, but I think you can go for the solution. If you want to find out, you can go for the solution also. Done, guys? Now let me ask you one more question. Let me ask you one more example to finding the integrating factor. The integrating factor, or find the integrating factor for the equation. We are having one more equation, and this time the equation is x dy by dx plus y is equals to x dy by dx plus y is equals to y square into log x. Is it x dy by dx? Yeah, exactly. X dy by dx plus y is equals to y square log x. So we have to find the integrating factor from here only. Now let's approach how we will find out the integrating factor. So we will go for, dear students, first of all we will write down the equation in a systematic manner. So it will be dy by dx plus y by x is equals to we have to divide the complete term with the help of, just remember one thing, we have to divide the complete term with the x only, because we have to remove this x. So that's why it will be y square into log x by x, right? Exactly. Y square into log x by s. Okay, exactly. Let's approach it. So it will be, let's find from here. So we know very well it's a non-linear or the Bernoulli's equation of the form dy by dx plus py is equals to qy to the power n. Can you approach it? Can you compare this? Yes, exactly. From here we can say the p, value of p is equals to 1 by x, exactly, and the value of q is equals to log x by x. Yes, exactly. Okay, and the value of n is equals to 2. Yes, exactly. So as we know very well, from the given equation we have to write down only three things. So we can say p is equals to 1 by x, q is equals to log x by x, and n is equals to 2 only, right? So now let's approach to the integrating factor, as it is only and only talking about integrating factor. So we can go for the integrating factor. It will be e to the power 1 by x into 1 minus 2 into dx, exactly, because the integrating factor will be, in this case the integrating factor will be e to the power p into 1 minus n, only with the slightly difference, that is the difference of 1 minus n only, right? Yes. So we can go for this one. Integrating factor will be e to the power minus, e to the power you can write down minus 1 by x, yes, exactly, into dx. So we will approach it e to the power minus log x, e to the power minus log x to the base e. So it will be minus, you can say e to the power log of x to the power minus 1. So it will be 1 by x only. So hence your integrating factor will be, guys, what? 1 by x. So you can conclude the answer that the integrating factor is 1 by x.